Hello students, my name is Anup Kumar Dutta. Today in my YouTube tutorial video of the new series of educational videos on NCERT Mathematics, which is completely free to you, I have just taken the question number 7 from the exercise 13.3 of your book class 10 under the chapter surface areas and volumes NCERT Mathematics. Now let us see what the question says. A cylindrical bucket 32 centimeters high and with radius of base 18 centimeters is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeters, find the radius and slant height of the heap. So, to proceed to the solution, we must have these pre-knowledges first. Number 1, since the conical heap of sand is made only from the sand which contains in the cylindrical bucket, therefore the volume of the cylindrical bucket is equal to the volume of the conical heap of sand. The mass of a body is directly proportional to the volume. Number 2, we must know about the mathematical expression which is used to find out the volume of a cylinder, which is pi r square into h, where r stands for the base radius of the cylinder and h stands for the height of the cylinder. Number 3, we must know about the mathematical expression which is used to find out the volume of a cone, which is 1/3 into pi r square into h, where r stands for the base radius of the base of the cone and h stands for the perpendicular height of the cone. So to proceed to the solution, let us draw two rough diagrams first. So this one is the cylindrical bucket. Which is full of sand. And according to question, the height of this bucket is 32 centimeters, and base radius of this bucket according to question is 18 centimeters. Now let us draw another diagram. This one is the conical heap of sand, and according to question, the perpendicular height of this conical heap height of this conical heap is 24 centimeters. We have to determine the base radius of this conical heap since this one is the perpendicular height of the conical heap of sand, so this point will be the midpoint of the circular base. We have to determine the base radius of this conical heap of sand. In this case, we will consider the base radius of this conical heap to be r centimeters, and at the same time we have also to determine the slant height of this conical heap of sand. Slant height of this conical heap of sand, and particularly in this question we will just consider the slant height of this conical heap of sand to be L centimeters. So after this, let us proceed in this way, write in this way. Since the conical heap of sand is made only from the sand which contains in the bucket, since the conical heap of sand is made only from the sand which contains in the bucket, therefore the volume of the cylindrical bucket is equal to the volume of the total amount of sand which contains in it is equal to the volume of the conical heap of sand. After this, proceed in this way. Here the height of the cylindrical bucket is, according to question, 32 centimeters. Base radius of the bucket is, according to question, 18 centimeters. Therefore the volume of the bucket is equal to pi into r square. That means the base radius of this cylindrical bucket is 18 centimeters, so we write here 18 square pi r square into h. Height of this cylindrical bucket is 32 centimeters. Pi r square into h. The unit will be cubic centimeters, so we will write here centimeters cube. After this, let us proceed in this way. Right now let the base radius of the conical heap of sand is equal to r centimeters. Height perpendicular, right within bracket, perpendicular. Now height perpendicular of the heap according to question. Height perpendicular of the heap according to question 24 centimeters. We have got the height. We have just considered the base radius to be r centimeters, so we can proceed in this way. Therefore, the volume of the conical heap of sand is equal to 1/3 into pi r square. That means it will be r square, which we have to determine 1/3 into pi into r square into h. Perpendicular height of the conical heap of sand is 24 centimeters. The unit will be cubic centimeters, so we'll write here centimeters cube. Now we can do cancellation here. 3 8 ja 24, which will be again equal to 8 pi r square cubic centimeters. After this, write in this way. Therefore, 8 pi r square is equal to pi into 18 square into 32, which again implies r square is equal to 18 square into 2 square, dividing both sides by 8 pi 2 square. Therefore, r is equal to 18 into 2, which is again equal to 2 18 ja 36 centimeters. After this, let us consider the slant height of the conical heap. So let the slant height of the heap is equal to L centimeters. Therefore, this one is the perpendicular height, so this will be the midpoint, so this one will be the base radius of the conical heap. So here we will get a right angle here, so this will be a right angle. So in this case, we can use the Pythagoras theorem to determine the slant height of this conical heap. So let the slant height of the heap equal L centimeters. Therefore L square, which is the hypotenuse of this right angle triangle, if we consider to be, so L square is equal to 24 whole square plus this one, the base radius 36 whole square. 24 whole square has been written in place of the altitude of this right angle triangle, and 36 whole square has been written in place of the base of the right angle triangle. So this is again equal to, we should actually try to memorize the square of 24. If we can't, we have to proceed in this way. 4 4s are 16, 4 2s are 8, 9 here, 2 4s are 8, 2 2s are 4, 6, 7 here, 5 7 6, 5 7 6 plus. In the same way, we should actually try to remember the square of 36 square. So if we can't, we have to proceed in this way. 6 6 are 36, 3 here, 6 3 are 18, 19, 20, 21, 3 6 are 18, 3 3 are 9, plus 1, 10. So 6 here, 9 here, 2 here, 1. 1 2 9 6. Now we have to add these two numbers, 1 2 9 6 and 5 7 6. If we add, we will get 6 6 are 12, 7 plus 9 17, 5 plus 2 7, 8, 1, 1872, 1872. Now if we try to find out the prime factors of 1872, we will get 2 9s are 18, 2 3s are 6, 2 6s are 12, again by 2, 2 4s are 8, 2 6s are 12, 2 8s are 16, again by 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 2s are 4, 2 3s are 6, 2 4s are 8, again by 2, 2 1s are 2, 2 1s are 2, 2 7s are 14. Now by 3, 3 3s are 9, 2 left, 3 9s are 27. Now 3 13s are 39. 1 pair, 2 pair, 3 pair. So therefore L is equal to square root of 2 square into 2 square into 3 square into 13 into 13, which is again equal to 2 2s are 4, 4 3s are 12, 12 square root of 13 centimeters. Therefore this one base radius of the hip is equal to 36 centimeters, and slant height is equal to, which we have just determined to be 12 square root of 13 centimeters. These are the answers. So this is all for today. Why not? Of course, I will expect your kind likes, dislikes, comments, subscriptions, and clicking on the bell icon. Thank U.